We have understood as to what exactly is a capacitance. We can find out, given a particular set of capacitance, what exactly is the net value of capacitance. So, given a amount of charge, given a capacitance and a potential difference that has been applied, how do we find out how much is the potential energy that can be stored in it? How much is the work that needs to be done on it such that that amount of potential energy can be figured out? Let's try to understand on that in the energy stored in a capacitor. Now, moving on, let's try to understand about how much is the amount of charge that is stored in a particular capacitance. So, let's try to understand about it. So, when we talk about this, it says the amount of charge and the energy that is stored is going to be given by this. And how do we get that? We know that Q equals to C into V. Further going on, we know that the work, how we are going to find it out? The work that we'll get is going to be equals to it's nothing but the potential energy that is stored, right? So if I say dW is the amount of work that we get, so this can be given by Q, because work done is nothing but the charge into potential difference. So I can simply say that Q into dV. So putting it all here, we can find out Q can be given as C into V. So this gives us CV dV. And therefore, if I integrate this, so I'll get the amount of work as equals to half CV square. So half CV square is nothing but the amount of work that you are required to do, such that you put two charges, or you charge up any particular capacitor by a potential V and which has a capacitance C. You can change half CV square into other forms as well. So this can also be given by Q square by 2C, just by representing in other forms as well, or you can also say half Q into V, right? So hopefully you understood till this particular point. So this covers, broadly speaking, all the major parts of the capacitor. Do stay tuned to understand about the Van de Graaff generator and some questions related to it. When we talk about the amount of energy that can be stored in a particular capacitor, the energy that is stored in a capacitor depends upon how much is the charge that is there, how much is the capacitance value, how much is the potential difference. But as you would see, at any instant of time, not all the three variables are going to be utilized. That's a very important fact. You should always remember that. Else the dimensional is going to become wrong. So for instance, it can be half CV square, it can be half into Q into V, or the other way around, that's Q square by 2C. So at any instant of time, only either charge or capacitance, charge or potential, or capacitance and voltage is going to be utilized for finding out the net value. This is the net work that is done, which is going to be stored in the form of potential energy. You will study later on, when we talk about alternating currents, that this amount of energy can be transferred to the case of inductor, and effectively that results in a kind of oscillating circuit. But let's leave that for later on. Hopefully you enjoyed till this point. Please stay tuned for the last part.